So we're going to look at some more solving or evaluating inverse trig functions. And this time we're going to take it a step further and kind of look at if there's inverse trig functions and regular trig functions. So a problem like this, where you have sine inverse of sine 5 pi over 4. It's kind of tempting to say that the sine inverse and sine cancel out. Unfortunately, they don't. So what we'll do is we'll start with the innermost function. Sine of 5 pi over 4 we know is negative square root of 2 over 2. Okay, so that takes care of the inside. And then if we want sine inverse of negative square root of 2 over 2, we talked about sine inverse exists in the first and the fourth quadrant. Since it's negative, we know that it's actually going to be down here, and so it's going to be negative pi over 4 for our answer. Okay. Now down here on this one, where you have sine of sine inverse of the square root of 2 over 2. So start with the inside function. Sine inverse of square root of 2 over 2. Again, sine inverse exists in the first and the fourth. Since it's positive, we'll focus on the first quadrant, and sine is square root of 2 over 2 at pi over 4. Okay? So that takes care of the inside function. Now we still have sine on the outside, and sine of pi over 4 is the square root of 2 over 2. So in this case, they did cancel each other out, leaving us with whatever was inside. But up here, it did not. And we're going to talk about that in just a moment. Let's do a few more examples first. Okay. Next, let's take a look at cosine of cosine inverse of negative square root of 3 over 2. So focusing on the inside first, cosine inverse exists in the first and second quadrant. Since it's negative, we're going to focus specifically on the second quadrant. And cosine is square root of 3 over 2 at pi over 6, and since it's in the second quadrant, 5 pi over 6. So this problem is now cosine of 5 pi over 6, which we know is negative square root of 3 over 2. Now, on this one, if we focus on the inside, cosine inverse of 1.2. Well, first of all, is 1.2 exist between negative 1 and 1? No, so that's a no solution, which means the whole thing is a no solution. All right, so here's the rules. Okay. So sine of sine inverse of x equals x if and only if your x exists between negative 1 and positive 1. And that's what happened here on this problem, because the square root of 2 over 2 exists between negative 1 and 1. So it ended up, they canceled each other out. Our final answer was square root of 2 over 2. Sine inverse of sine of theta will equal theta as long as your theta value is between negative pi over 2 and pi over 2. Okay. Our very first example that we looked at, 5 pi over 4 is not between negative pi over 2 and pi over 2, so we couldn't just say they canceled out. We actually had to go through and do all the work for it. Cosine of cosine inverse of x equals x if and only if x exists between negative 1 and 1. And cosine inverse of cosine of theta equals theta if and only if theta exists between 0 and pi. And then tangent of tan inverse of x cancels out and leaves you with x as long as x is any real number. So that means that's always going to work, which is really nice. And then the last one is tan inverse of tangent of theta equals theta only when theta exists between negative pi over 2 and positive pi over 2. All right, so looking at a few more examples. Let's see. So this one starts off tan inverse of tangent of pi over 4. Well, pi over 4 exists between negative pi over 2 and pi over 2, so we can just say that by this rule, we know the answer is going to be pi over 4. But that's also on the unit circle, so it's not like it would be difficult to take the time to do this. Tangent of pi over 4 is 1, and then tan inverse of 1, keeping in mind that tan inverse exists in the first and the fourth. It's positive, so we focus on the first. We know tangent equals 1 at pi over 4. So whether you use the rule or you work it out, each step, you should get the right answer. Now, the rules are nice when you're dealing with a problem like this one, because 4 pi over 5 is not on the unit circle. However, it does exist between between 0 and pi. So based on our rules, we know that this answer is that those will cancel out, leaving you with just 4 pi over 5. Down here, sine of sine inverse of 1/4. Well, 1/4 is not one of the nice points on the unit circle, but it does exist between -1 and +1, which means those cancel out, and your answer is just 1/4. Oops. Now, let's take a look at this one. So if we have tan inverse of tangent of 5 pi over 4. Now, 5 pi over 4 does not exist between -pi over 2 and pi over 2, which means you have to work it out. All right. Now, 5 pi over 4 is on the unit circle. Okay. And it is in the third quadrant, and tangent's positive in the third quadrant, so that inside function, that whole thing, is 1. So this becomes tan inverse of 1, and we actually just did that, so we know the answer is pi over 4. All right, now down here, we can't use those rules because there's a cosine and the sine inverse. All right, so clearly they're not going to cancel each other out. So we just work it out. Sine inverse of the square root of 2 over 2 is pi over 4. And this becomes cosine of pi over 4, which is the square root of 2 over 2. Happy coincidence. Not always going to work out that way. All right, next one we want to look at. So if we have one like this, cosine inverse of negative square root of 3 over 2. Cosine inverse exists in your first and second quadrant. Since it's negative, we'll stick to the second quadrant. Since it's square root of 3 over 2, we know it has to be a pi over 6. Since it's in the second quadrant, that would be 5 pi over 6. And then we still have the tangent on the outside, so we're taking tangent of 5 pi over 6. Since tangent is negative in the second quadrant, your answer is negative square root of 3 over 3. All right, now down here, cosecant of sine inverse of 1/2. Focusing on the inside part first, sine inverse of 1/2. That's going to be in the first quadrant, and the sine is 1/2 at pi over 6. So now this becomes cosecant of pi over 6, which is 2. All right. Now, let's take a look at this one. We've got cosecant of tan inverse of 1. Focusing on the inside here, we know that tan inverse of 1 is pi over 2. I'm sorry, pi over 4. Okay. And then cosecant of pi over 4 is the square root of 2. And that's your answer. Now let's take a look at one where maybe the inside number is not a nice point on the unit circle and you can't use the rules either. All right, so let's take a look at this one. We've got cosine of sine inverse of 1/3. Now, if we focus on the inside here, we know that 1/3 is not a point on our unit circle, but if I take this out, I know that sine inverse of 1/3 has to equal some angle measure theta. We know that. So what this means is that 1/3 equals sine of theta. Now, sine of theta is defined to be y over r. So if we know that y is 1 and r is 3, the one we need to look for is x. Okay, so if x is what we want, we'll use our unit circle equation, x squared plus y squared equals r squared. So that becomes x squared plus 1 equals 9. So x is going to equal 2 square root of 2. So we don't know exactly what this theta is, but we know that cosine of that theta value is going to equal our x value over our r value. So our answer is going to be 2 square root of 2 over 3. Let's take a look at one more like that. All right, so let's say we've got tangent of cosine inverse of -2/3. Clearly, -2/3 is not one of our points on the unit circle. So we'll set it up like we did the last one. Cosine inverse of -2/3 has to stand for some angle measure theta. Okay? And also this angle measure theta has to exist in the second quadrant since the cosine inverse is negative there. All right, so in order for this to be true, then -2/3 has to correspond to cosine of theta. Well, cosine of theta is defined to be x over r. So y is what I need. I know that x is -2. I know that r is 3. So in my equation, x squared plus y squared equals r squared. I've got 4 plus y squared equals 9. So y is going to equal the square root of 5. So doesn't matter what theta is. I know that whatever theta equals, it corresponds to a y value of square root of 5, an x value of -2, and an r value of 3. And if you know those values, you can find any of the trig functions. The one we specifically want is tangent of this theta, and we know that tangent is defined to be y over x, so our answer is the square root of 5 over -2. Or if you like, negative square root of 5 over 2. There we go. And then your homework for tonight is a worksheet that Mrs. Morrow will give you. And I want you to do numbers 1 through 29 all. Good luck.